Live. We'll wait and see. We'll let everybody get into the room before we start the class. If you would, as you come in to the live, put down where you're from and what kind of experience you're looking for, or what level of experience you're at. Put down where you're from and what kind of experience. Let me turn this stuff off. Hang on just a second. All right, so I got the volume. I got a bunch of stuff going on here. So I'm hooked up to the other with my other phone so I can see the comments. We'll just wait a little bit. It takes about 5 or 10 minutes for the algorithm to start pushing things out. And I'll try to keep track of the comments best I can, because I'm a ways from my monitor. But I got this phone, so we should be able to see your guys' comments. So what we're going to teach tonight is basic automotive ignition theory and operation. Teach you how to test. And I know a lot of people say, oh, this is old technology. This is ignition system with points. But that's the basics of ignition systems. If you understand a point ignition system, you'll be able to understand a solid state ignition system. So we'll wait around. Hopefully we'll get, it usually takes a little bit for the algorithm to do its thing. And then you'll get like 20, 30 people all at once drop into the live. So anyway, as you come into the live, just drop down where you're from or what your automotive background is. We're going to teach this at a really basic level tonight. So, just for the basic person that knows nothing about automotive. So if you're like a guy in a shop, this is probably not going to be the live for you. But we can we'll get up to that point. We're just trying to teach the masses right now. And we'll see, let's see what we got in here. Well, it looks like the notification just went out. So it takes a little bit to get people into the live. Anyway, so my name is Go Big. I've had 40 years experience in the automotive industry. Let me get over here where you can see me. I got 40 years in the automotive industry. So we thought we'd start doing Tuesday night teaching, where we're going to just start teaching basic automotive. I've done some teaching in the past. I'm an ASD certified master technician. I've been in the field for 40 years. I basically do automotive electrical and troubleshooting. So I thought tonight we would just teach a basic class on ignition systems, talk about how to use a test light, basic meter operation, and just try to keep it pretty simple. If you guys would, in the links, I've got some recommendations for some tools we'll go over. Before the night is over, I'll talk about them. They're tools that I've used in the past, and they're a good deal. Matter of fact, there's a really good deal on the tool right now. If you don't have any tools at all and you're putting a toolbox together, we got a good link for like a Craftsman set. It's on sale for like 69 bucks. It's a pretty good deal. So anyway, we'll wait just a little bit and see, and we're going to get going here. I'll give it about 5 more minutes. What you guys been up to? We got any locals? We got any of our usuals in here tonight? We got a pretty good crew of guys that come in here all the time. We'll wait and see how many people we get in. Ivory Menace, welcome to the live. We're going to get started here shortly. We're just going to go over basic ignition theory and operation. Be more like a classroom setting. But we do a little chit chatting along the way. But give you guys some tips and things that I think you should think about. I've been doing this for 40 years, so this is Go Big Garage. This is our first teaching live, but I've done some teaching in the past. You guys let me know. We'll get started. Let me know if I know my artwork is not up to snuff. But the whiteboard works good because you could use SketchUp, but the whiteboard works good because I can just go off into things that I think about as we're teaching. I'll try to stay out of the way as we're doing this. Can you guys see the diagram okay? That was kind of a concern of mine that you won't be able to see the diagram very well. We'll start walking. I'm not sitting through this. Okay, you don't have to. We're not forcing nobody. You probably pay a lot of money for a class like this if you went to like a OTC class or something like that. All right. Easy money. How's it going, buddy? Can you see the diagram all right? And how's the audio and the lighting? Is the lighting good? I can turn the lighting up some if I have to. Let me know. We'll get going here shortly. We're going to teach automotive ignition systems tonight. Should take about an hour, maybe two, depending on how in depth you guys want to go. And everything's good. You can see the diagram. Okay. Sorry for the artwork. I'm not much of a artist. We'll get going. I'm going to really go basic here. So tell me if I'm going too basic on you guys, because I'm going to go pretty basic. Because we might have some people here that's never, ever even like picked up, knows even how to get the hood open. You know what I mean? So we're going to go to that level. And if you're seeing this on the replay, if you would just leave a comment, what you thought of the class. We're going to be doing these every Tuesday night. We'll be going through these. So I'm going to go ahead and get started. And remember, I'm looking at the board, so I may not see your comments right away. It'll take a little bit for me to get back to the comments. So what is the purpose of the ignition system? You know, why do we have an ignition system? The ignition system's job is to introduce spark in the combustion chamber where the piston is at. Call that a piston. And so how it happens is a time spark is introduced in the combustion chamber, usually as close to top dead center as possible, usually around 6 to 12 degrees top dead center. And to ignite the fuel, so the engine head pulls in gases and air right here. As it comes, goes down, it sucks in the air and fuel. And as it comes up, it comes into a compression stroke. And at that point, you want to introduce a high spark. And the purpose of that is, think of a fuse on a firecracker, you know. The fuel is there, it's sitting there, it's ready to explode, but it needs an ignition source. So that's what the spark is about. And that's why we have spark plugs. And the ignition system's job is to introduce the spark into the cylinder at the right time. So how do we do that? So we're going to talk about battery briefly. What is a battery? What's the purpose of the battery? The battery is basically the reservoir where the voltage or the power lives. And let me give you a safety tip right now. You see a lot of people storing batteries. Hope I'm not standing in your guys' way. Just a little bit. You see a lot of people storing batteries, and they're just sitting on the ground. You know, I see that all the time in shops. It's really dangerous to do that, and I'll tell you why. If you arc across this positive and negative, and I'll talk about positive and negative for you people that don't know anything, is if you arc across there with a piece of metal, that piece of metal will glow like it will glow like a heating element on your stove. So I see this a lot where batteries are just laying everywhere in the shop. And what can happen is, let's say you got this battery sitting underneath your bench at your shop where you're working, and you got a bunch of tools up here, and the cat gets up there and knocks a wrench off, and it goes across like that. Well, now you got a fire hazard. The thing could blow up, it could light your garage on fire, it can do a lot of things. So what I tell people, if nothing else, when you're storing batteries like that, take some black tape and wrap the tops of these posts with some black tape. At the bare minimum, you know, that's just a safety precaution. Okay, so for you that never had dealt with a battery has a positive and a negative, and it'll be listed on the battery, positive and negative. Any kind of load that you try to, like let's say you want to have a light up. Well, it has to have a power and a ground. So let's say this is a light bulb, right? It has two fittings on it. One has to find power and one has to find ground for that light to light. So any circuit in a DC voltage system has to have a power and a ground. That's the basics. So in other words, it has to find both sides of the battery, whether it be at the battery or the fuse panel or through a key switch or whatever. And the reason I got this little line here, it looks like water. I want you guys to think of the battery like a bucket of water. That's the best way to really understand how voltage works. Because like, okay, you see this battery I have drawn right here, and it shows water in it. So what would happen if I made a hole right there? And I just put a valve and I start dumping that water out, what would happen? So this will be flow or amperage. And over time, what happens if you don't recharge that battery, the voltage is going to drop because you're using it up. So that's a good way to look at electricity, is like water. So let me walk you through the ignition system real quick. How does it work? So basically you have a coil, you got a battery that supplies it power, and then the ground side of the, I didn't write that in right here. So this is the negative side of the coil right here. We'll bring it down, and these will be your points. So inside the distributor, there's a set of points, and what the points do, they open and close like this. And the way they do that, there's a rubbing block that as the shaft rotates, it opens and closes those points. So let me talk a little bit about the coil and how it does that. So what is a coil? Basically, a coil is just two sets of windings. Like right here, I'll show you. So you have a primary and a secondary set of windings. So you got a big wound of wires going like this around inside the coil, and it comes around here to the negative. And inside there's a really coarse wire called the secondary. And how a coil works, when it sees power and ground, when you ground that, it creates a magnetic field. And a spark occurs when you remove the ground. And I'm going to show you that on the bench tonight. I got a setup here. So we're going to go through what actually makes the spark occur. A lot of people think the spark occurs when you apply voltage. Well, that's not true. What actually happens is when you open and close the ground, that's when the spark occurs. It doesn't occur when you apply the ground. It occurs when you remove the ground. And the reason why that is, when you go power to ground, okay, this magnetic field is built up in that primary. And they have what they call flux lines. And so when you remove the ground, the magnetic field collapses. And when it collapses over a secondary set of windings, that's what creates a 30,000 volt spark that comes through this wire and enter the combustion chamber at the spark plug. What we're going to show tonight is a very easy way to check to see if your points are working. Very simple. So basically the ignition system's job is to, hey, I have a cylinder over here. It's full of fuel and air, and I want to make it explode. I'll force this piston to go down, and that's what its job is. It wants to introduce the spark close to top dead center so it can force that piston down, and that's the basics of an internal combustion engine. And we can go over the strokes, but I want to stay on the ignition system. We can go over the intake, compression, power, exhaust after we go through this. But I want to show you a really some easy tests with a coil. So we're going to talk about a test light and a meter tonight. I'm going to show you this is what a test light looks like. It's just basically it's a tool. It has a a clamp on one end and a tip on the other. And sometimes you'll attach this to the power side. Whenever I say power side, I'm talking about the positive side of the battery, or typically the red side. Red is typically power, but not always. Don't pay attention to color because it'll get you in trouble. People a lot of times will put the wrong color cables on the battery. So just remember, if you're checking for a ground, you're going to hook this to power. And when I say ground, I'm talking about the negative side of the battery. There's a positive and a negative. So if you wanted to check a ground, you would hook this to positive, and you would hook this to what you think is a ground. If the light comes on, you have a ground. If you want to check for power, you're going to attach this to the ground side of the battery, which is the negative side, and then this should light up when you see power. So we'll walk through that, but I'm going to teach you some simple tests you can do with a test light. So let's say no matter what this is a, get out of your way here, you're in the way. You know what, I hope I haven't been blocking you guys. I've been looking at this other screen. Hopefully, yeah. Okay, I'll look at your comments after I get to a certain point here. So typically what happens is when you turn on the ignition, you get in your car and you turn the ignition switch on, what happens is the current goes from the battery, it goes through the key switch, and it finds its way out to the positive side of the coil. We'll talk about this resistor. There's a resistor in there, I'll talk about that. Let's keep it easy. So basically, you turn your key, power goes out here to the positive side of the coil. It goes through those windings, and it's sitting right here on that terminal. And what is the coil waiting for? The coil is saying, hey, give me a ground, and I'm going to fire that coil. I'm going to fire that plug. So that's what the points do. So all the points are doing is they're grounding and ungrounding this wire. So that's the job of the points. So if this point loses their ground, they can't fire the coil. And I tell people that a lot. If you want to build a real easy system to keep people from stealing your vehicle, find the negative side of the coil, bring a wire down, put a toggle switch, and put it to ground. If you ground the coil, you cannot start that car. It has to be open and closed in order to fire the coil. So I'm going to show you a really easy test. So normally when you look at a distributor that has point ignition, it has one wire going into the distributor. Well, that's the wire that goes into the points. So what you can do, you can just disconnect this wire right here, put a wire right here on the negative side of the coil, and just give it its own ground. When you ground and unground that wire, that's all the points do. So you can just take that wire, go over to the negative side of the battery, ground it and unground it. When you disconnect that ground, that coil should fire. And you should get sparked out here at the end of this lead. So what are some things we can do? With a test light, we can take our test light, we can hook it to the negative side of the battery. We'll do this on the bench tonight, just so you guys got to understand. So if we were going to check this coil for power, one thing we don't know is when we turn the key on, do we have power? That's the first thing you should be looking at if you have no spark. Real simple. You turn the key to on, you hook this to negative, you come right here, you should have, your light should light. If you come to the positive side of the coil like this, I'm not blocking your guys' view. If you come to the positive side of the coil like this, with the key on and it doesn't light, you know you got a problem from the key back. It's not the coil, you just have no power to the coil. So let's say you do have power here. If you have power here, you should have power on the other side of the coil, unless the points are closed. So what you can do, if you want to check the points, you can just put this, test light on this wire that's coming out of the points. And you can just disconnect it completely, put this on power, put this on the wire going in the distributor, and crank on the car. This light should flash. It should go on, off, on, off, on, off, because that's what the points are doing. It's providing a ground. If you go power to ground the battery, the light lights, right? So when you go to the points, when you rotate the motor, that light should flash. It should go on, off, on, off, on, off. You come to this wire that goes into the point. Let's say you disconnect it here, you put the lead right on this wire, disconnected from the coil. If you crank that and this light don't light, you know what it tells you? Either the points are bad, they're disconnected, or they're dirty. I'll tell you a situation I just had on that boat. On that boat, I just did that whole test. And when I went to the points right here, I had no light. So I knew there was no ground for the coil. That's why I wouldn't start. And let me show you. So I'll show you what a set of points kind of look like. So inside the points, there's two arms, right? And a set of contacts like this. Can you guys see that? Can you make out those points at all? Somebody comment. Can you see that? I'll make it bigger. You can see it better. So a set of points has two sets of contacts. Like this. It has an arm. Okay. The one side here goes to ground. This side is the wire that goes over to the coil that we're talking about. So when these points open and close, it's just providing the ground. That's all it's doing. What can happen on my situation, I had no light at all. So I knew either the points were missing, they lost their ground in here. If you lose the ground inside where it bolts to the distributor, you won't get no fire. I pulled the flywheel off, and what I found was I closed the contacts. So I made them so they were touching. So they look like this. So when I do that, I should have ground everywhere, because this is ground, this should be ground, that should be ground, the end of the wire should be ground. And what I found was when I came to the ground, I had ground here, the light lit. I had ground here, the light lit. And when I moved over to the other set of the contacts, I had no light. So what did it tell me? It told me either the points were open or wore out, or they had debris there. And what I found out was they were just dirty. And what can happen with points is they can get like little burns and little jagged pieces. And if they sit for a long time, they can get corrosion. So just like a connection. So when they closed, it wasn't allowing the coil to fire because it couldn't find ground. So just remember that the point's only job is to ground the coil. It's just looking for a ground. It's sitting right here and it's going, okay, coil. The coil's sitting there, okay, points. All I need is you to do is ground me and unground me, and I'm going to follow that coil. And that's how we get timing. That's how we end up with that's how we adjust timing. You know how you always turn the distributor to adjust the timing? Well, you're adjusting when the spark actually enters the cylinder. By turning that distributor, you're changing when this comes into the distributor. So remember that a very good test is to just take this wire off take that wire right off the coil, put your jumper on there, and then touch the battery negative side like that. When you do that, every time you do that coil should spark. It should fire the coil. And if it doesn't, then you start looking at, okay, maybe I got a bad coil. Because if you already know you have power all the way through here, and when you ground it, it fires, you know the problem's in the points. It's not providing a ground. Let's talk a little bit about this resistor and what's this about. And this doesn't really come into play anymore, like on solid state type ignition systems. But the purpose of this, so normally if you check voltage with a meter, you'll have 12 volts at the battery, but you only have about 9 at the positive side of the coil. And the purpose of that is so you eliminate a lot of the arcing that goes on. By reducing the voltage, you don't get as much arc. If you run full battery voltage at those points, if you have a car and it seems like every time you turn around, you're having to put points in it, and when you look at them, they're all burned up and got big pits on them, it's because you got 12 volts to the coil. You need to put a resistor in there. I don't know if you guys ever noticed the resistors on the firewalls on the old trucks. They usually were white, and they're about this long, and then they just look like a little ceramic element. That's what they're for. They run power through that resistor to drop the voltage to get it down to 9 volts. That way you don't burn up the points. The other thing they do, I don't want to lose my little, give me a second. Set my little thing down. Okay, there it is. Oh, drop it on the ground. The other thing they do is during cranking, so like key on, you're going to just get what I show you. But at the ignition switch at the crank circuit, they send 100% 12 volts to the coil during cranking. So what that does, it gives you a nice hot spark during cranking. So there's a bypass on the key for crank only on a lot of the older cars. So they'll bypass this resistor, send 12 volts straight to the coil during cranking. But when you let off the key, you're going to get this 9 to 10 volts. I don't know if you guys ever had cars that it seemed like when you cranked on them, they didn't want to start, and when you let off, it would fire. What's happening there is you've lost this crank circuit. And when you crank on it, there's no power going to the coil. But as soon as you let off, then it goes to the resistor and fires it. I've seen so many cars that are like that. You get in them, you crank on them, the whole time you're cranking it, it won't fire. As soon as you let off the key, it fires. You've lost the crank circuit. You've lost the crank circuit to that coil. So go in there with the key. What you do is you put a test light here, and you crank on it and watch for the light to light. If you don't get a light here during cranking, you've lost this bypass. We call that ignition bypass. So it gives full 12 volts to that. What else can we talk about as far as the coil goes? So there's some tests you can do. You can do resistance tests with a meter. I'll show you what a meter looks like in case you guys don't know. I'm sure most of you do. But we don't know who's in the room tonight. So a multimeter basically looks like this. Let's see what you guys can see. Multimeter basically looks like this. It has a dial on it. You just tell it what you want to measure. A lot of time it's DC voltage. If you want to check for continuity, and we'll have a class just about the meter. But you set this to what you want to measure. Like on this one, I set it to 20 volts, right? The black goes to ground or the negative side of the battery, and this goes to the positive side of what you want to measure. So what you can do with this, you set it to ohms, which we won't go into ohms just because I don't want to confuse anybody. But what it does, it gives you a reading of resistance. And on a coil, you can go across the positive and negative, and you should get a reading. If you go positive and negative and it's open, you got a bad coil. Like I said, I don't mess with this much. To me, if I can provide a ground and that coil fires, I know it's a good coil. I'm done. I don't have to go through and check for resistance. The secondary resistance can change. For the most part, usually a coil is either good or bad. And when you get a bad one, usually what you'll feel in a coil that's going away, it feels like the car's running out of gas. You'll be going down the road, you get into it hard, and all of a sudden it just feels like the fuel filter's plugged up. That's exactly what it'll feel like. A bad coil will feel like a fuel problem. it'll feel like it's running out of gas. And so let me talk a little bit about solid state or the new ignition systems. And what is the difference here? The only difference between the new technology ignition systems and this is how we fire the coil. We used to use a set of points. Well, this is going to go to a module, right? The module can be a small module inside a distributor. This can be controlled by the ECM or the computer. So what this does, it does the same thing. All the concepts are the same, other than this module is sitting there going, okay, I see a crank signal. The coil wants me to fire it, and then it provides the ground like before. Right? That's what the module does. It's still hooked to a coil. It still needs power and a ground. The module also needs power and a ground. But the module is just a small little computer that says, hey, I'm going to control what the coil does. It does that by inputs, like it might have a Hall effect switch to tell it where the top dead center is at, a couple little different signals, but not to get too complicated. The module's job is to say, hey, my job is to ground the coil when it's needed. It takes in information, input, sensors, and it says, okay, I've seen a crank signal. The coil won't need the ground. Okay, I'll give it a ground. And then this module might talk to the computer and say, hey module, I want you to give that thing 10 degrees timing. And it can do that, and it can adjust the timing. So it's just and what you get rid of by going solid state is you don't have a wearing part. Points over time look like this, right? We talked about what the contact looks like, but also where the shaft is at, there's a lobe. And when that lobe goes around, depending on how many cylinders you have, you'll have that many lobes. But what happens, this little contact, there's a little contact area here. What happens is over time, that contact will wear out. And as it wears out, the points get closer and closer together. Eventually, the points won't open, and then the car won't open. So that's the downside of points, is that they wear. The contact, where it contacts the lobes, this hard piece of plastic wears out, and it gets smaller, and then the points close up. It takes a long time. You just have to go in and adjust them every once in a while. What I like about regular points, out in the field, you can just adjust them. If you have solid state ignition and it stops working out in the field, you're walking. Let me see. Let me look at my notes real quick. We talked about. So that's pretty much how ignition system works. Power comes from the battery. The negative side goes to the distributor, and then the points open and close the coil. And we're going to show that on the bench. I got it set up here where we can show. We're going to fire our coil up here on the bench to show you how that works. See if I missed anything. Let me look at your guys' comments, because I can't do that at the same time. You're intermittently, I'm pretty sure. Till next week. Hey, suppressed. We'll do some on Wednesdays. We're going to do that question and answer stuff. Maybe we can get to it tonight. Yeah, good job. suppressed. Yeah, it actually can. If you got a problem with your ignition, absolutely can give you a hard start. Digital multimedia voltmeter, both devices usually measuring capacitance easy with an analog view. We have a diode measurement feature. Yeah. So I didn't want to get too complicated. That's why I kept it a little simple. But yeah, good job, Clutch and Stick. So what a diode is, a diode only allows current to go in one direction. We'll talk about that when we get to alternators. Is that a lot of people miss alternator problems that they have a bad diode in it. So what a diode does, it only lets current go one way. There's a way to test it with a meter. And if you guys are looking for a good meter, there's a meter listed in the description, a basic fluke that's like $100. I think it's like $110. So that's a good. Let me talk a little bit about a tool that I really like. So I do a lot of troubleshooting at work, and I have if you have never seen one, go look, and the descriptions in the description. There's a link for it. A power probe is like a test light on steroids. So what it does is when you touch power, a red light will come on, and you know that you're on the positive side of the circuit. When you touch ground, a green light will come on to tell you that it's on the negative side of the current. And it has a rocker switch on it that you can either apply power, 12 volts, or you can apply a ground. And it's really nice for doing troubleshooting. And they're not crazy expensive. You can get just the power probe for like $130, I think. But the nice thing about it is it has a really nice long set of leads that'll go from the front to the back of the vehicle. And I don't know if you've ever been back there making up leads and trying to test stuff and clamping stuff on there. It's a pain. This makes it real simple, man. You just go power, ground, it lights up. It has a little light on the end so you can see. It makes a beeping noise so you know it's powered up, and you just walk back there. Let's say you're working on a brake light on the back of the truck, and you don't know, is the bulb burn out? Did you lose the power? Did you lose the ground? Real simple. You go power ground, you walk back there with the power probe. It's got like a 25-foot set of leads on it. You pop the bulb out, check the power, check the ground. If you want to apply power to the bulb, you can. If you want to apply ground to the bulb, you can. So you can check power, you can check ground, you can apply power, you can apply ground. Super great tool for doing drivability. Especially if you're up underneath the dash trying to do testing. When you power something up, you just push a button, power it up. You need to ground something, you just ground it, and then it gives you that red and green. If you're going to buy a test light, I got one listed for people that are just starting out. If you just want a good test light, OTC makes a pretty good one. I have a Snap-on that I really like. The OTC one's listed. It's like under $20. But, you know, if it was me, if I was thinking about getting into doing this and I was going to be doing a lot of troubleshooting, I'd just buy a power probe. For $130, it'll be the best test light you ever bought. Anyway, there's links in the description for that stuff. Hey, Will, how you doing, brother? You smell wires burning. You should, man. My brain's on fire. I was scrambling today trying to get all this stuff ready. I was hoping we'd get a better turnout tonight. You know what? That's the way it is, man. That's the way YouTube is. It's a grind. You guys got any questions that I can answer for you so far? You understand? Am I getting too deep? Or you guys understand where I'm going at with this? So it's pretty. Some of you guys have some experience, so this is just basic stuff for you. But I'm trying to teach for the people that never done any automotive at all. So I had to go get underneath the hood of my old Chevy and pull a coil out so I could set this up on the bench today. You know, that's one of the things I've been trying to push is like once you learn ignition systems, it doesn't matter. It doesn't matter if it's a boat, a truck, car, you know, a lawnmower. Once you understand how ignition works, like that boat, I just got that boat. I'm not a boat mechanic. But I opened it up and I seen that it had 2 coils in it. You know, it had condensers, so I knew it had a set of points. Well, that's something I didn't go over on a ignition system, and that's what'll happen. Let me bring that up so I don't forget. There's a condenser that attaches to the negative side of the coil. Basically, what it is just a round caster with one lead coming out of it, and it's got rolled up tin in it. And it's like a shock absorber for the voltage. And what you'll find, if you don't have a condenser that's working correctly, you'll have yellow spark. When you look at spark, when it fires, it should be nice and blue. We'll talk a little bit about voltage. So basic voltage in an ignition system, like a basic older truck or something, you're looking at 30,000 volts. HEI distributor, about 80,000 volts. Once you go to a distributorless ignition, DIS, where it doesn't have a distributor, it just has sensors, upwards of over 100,000 volts. Let me tell you something. When you get hit with DIS, you know when you get hit with DIS. You want to be careful around distributorless ignition. Don't be sticking your hand down in there unplugging stuff. You wish you didn't, because it'll feel like somebody tried to jerk your arm off. DIS is no joke, man. It'll light you up. So anyway, there is a condenser on the negative side of the coil. Somewhere in the circuit, there's a condenser. It usually looks like this, and it goes to ground like that. It's just a separate lead hooked to the negative side of the coil. That's why a lot of times you'll see two wires on this. One's going to the coil. Sometimes this is inside where the points are at. It depends on how it's designed. Like on that boat, they were separate. So I fixed the boat because I know basic ignition. You know, I'm not a boat mechanic, but I lift it up. It's got coils. It's got points. It's got, you know, I checked for power. I had power on the one side of the coil. Well, I had to do some wiring in there. But once I got power to both sides of the coil, I knew the coils were good, or I knew that they had continuity because I had power out the other side. And so when I cranked on it and I put a light on there, the light didn't flash. So I knew the points were the problem. So by knowing basic ignition, I was able to pick that boat up pretty cheap and fix it by just taking the flywheel off, getting in there and cleaning the points up, and it runs. And I learned a lesson about both by the way. You know, you learn things sometimes just the hard way. And I did yesterday. I learned a lesson. I've been doing this a long time. And what it was is the cable was off, and I was trying to get the throttle cable adjusted correctly, and there was a big long screw in there. And I was like, well, that's got to be the throttle stop. So I adjusted the cable so that throttle stop was against its stop, so I could adjust idle. Well, come to find out, that big old bolt was the maximum RPM. What I did, I set the cable up backwards. I had it at full throttle. I fired that thing up, man. That thing was like, wow! And I ran to the front and shut it off. I could have blew up that motor, you know. So, you know, pay attention when you're working on something you're not familiar with. You know, you might bite you in the butt if you're not careful. But anyway, long story short, we used basic troubleshooting with the boat. We turned it over. It had compression. I didn't put a gauge on it, but I could feel it had compression. I knew it had no spark, so I went into that. I found the points were the problem, and more than likely, somebody had been working on it because the nut was off the top of the flywheel. But I think they stopped because they couldn't get it off, and they actually broke a little piece off the flywheel. You need a puller to get that off. So I think they stopped. Hang on a second. I'm about to lose you. I have to plug in my charger. Give me just a second. Think that, boys. Yeah, there's so many wires live. You got to hook it up. You get one little thing, man. You could lose everything. All right, perfect. So by knowing basic troubleshooting, I was able to pick up that boat dirt cheap, and you know, just by understanding ignition, basic intake, compression, power, exhaust, I was able to fix it for almost nothing. I put two new spark plugs in it, mixed up some gas, and that's all the parts I got in this boat right now. It was just, you know, the ignition, the points were dirty, so they couldn't find the ground, so it couldn't fire. So we had compression. Now we got spark. It has fuel, but I have a fuel issue. It's wanting to idle up really high. So I'm going to pull those carburetors off, see if I can kit them. But I think we're going to have a pretty decent little boat out of that just by doing the troubleshooting, you know, on the fuel system. Let me go through four-stroke real quick. Are you guys got any questions on the ignition before I take this off the board? I'm going to pull this down. Let's, you know, I know some of you guys, there's guys here that have some skills. They know all this already, but we're gonna try to keep it really simple. Because we've had people that come in that's what they're looking for. They want the simplicity of see how my drawing, see how well I can draw. I'm not much of an artist. Yeah, I figured that out. We'll make this a Hemi. No, let's do this. I want to explain intake, compression, power exhaust. So four-stroke. If you've never heard, you know, what is a four-stroke? That means the piston goes up and down 4 times for every compression stroke, for every stroke downstroke. I'm just going to explain this on general terms. So what's the purpose of all this? The purpose is right here we have a crankshaft that has a bunch of pistons hooked to it, depending on how many cylinders you have. And the purpose of all this is we want to create an explosion up here that forces a piston down that turns the crankshaft. And how do we do that? So in every motor, four-stroke motor, you have 2 valves. You got an intake and an exhaust. So the pistons here, let's get it a dome, make it a dome top. So here's the piston, comes down, has a little hole in it right here, and this is attached to the crank. Bad drawing, but that's what it is. So how does it work? God, I can't tell from here. Let me do it from this side. How does this work? So these 2 valves, think of them like 2 holes in a cylinder, like think of a 2-liter Pepsi bottle. If you suck on a Pepsi bottle, you know, no air comes in because it's closed. So what happens is when this piston goes down on the intake stroke, this valve opens. This one remains closed. As the piston comes down, it's sucking air into the cylinder through the intake. So air's coming in. That's a bad drawing. Let's go like this. Air's coming in this way. So as the piston goes down, this valve opens and it sucks in the air and the fuel. It goes around, it starts to come back up. When it comes back up, it's on a compression stroke, and you want to squeeze that cylinder. You want to squeeze all of this air and fuel so you can explode it with the spark plug. So how do we do that? On compression, this valve closes. So both valves are closed during compression. So as that Piston comes up, it's squeezing and making really high pressure out of that air and fuel. The power stroke is when the explosion happens. When this thing goes boom, it pushes that piston down fast and hard. And that's where the power comes from. That explosion pushing that cylinder down is where your power comes from. So you got intake, or actually down is intake, compression, power, and then when it comes up the next time, it has all this unburnt or burnt fuel in there. So as it comes up on the 4-stroke, this valve opens and it lets the exhaust out. So you got intake, compression, power, exhaust. Intake, compression, power, exhaust. And that's how an engine works. It's just trying to turn this crankshaft. And it does it by creating an explosion at top dead center. And it does that by opening up these valves. It opens up the intake, lets the fuel and air in, goes down, comes up, it closes the valve so it can compress. It explodes, it goes back down on the power stroke, and then as it comes up the next time, it opens this to let the exhaust out. So that's the basics of a 4-stroke engine. Intake, compression, power, exhaust. And that remains true for whatever you're working on. If it's a 4-stroke motor, that's the way it works. I don't care if it's a little car, big truck, airplane, motor, motor home, a boat. That's how it works. 4-stroke engines, that every 4-stroke you work on, that's the way it operates. And we can go into detail about exhaust overlap and cam lobe lift and all that stuff, but that's the basics of a 4-stroke engine. And that's why when we were talking about the ignition system, why that was so important. Because let's go back to our intake, compression, power, exhaust. When that thing comes up on the compression stroke, that's the spark plug's job, right? To introduce a spark inside that combustion chamber when it reaches the top of the compression stroke. So when the piston's coming up and it gets close to top dead center, the spark is created. Think of it as a fuse on a firecracker. It creates a spark and it goes boom, and it blows that piston back down again. So that's the basics. So that's what the purpose of an ignition system is. Let's talk about coil on plug for a minute. Coil on plug is a new system that we use on a lot of things called COP. I think Ford was the first that came up with it, but nothing changes. So what we did on a regular distributor, right? We got spark plug wires going to each cylinder. Man, is that a bad picture of a distributor or what? Low power. So that's how a distributor works, right? It distributes the spark to each cylinder based on the firing order. So on coil on plug, what we did, we got rid of all that. We got rid of all these plugs, wires. Plug wires were a problem forever, and they still are. They fail a lot. It's probably one of the most failed parts on an ignition system, old ignition system, is plug wires. And I'll give you some, let me remind you guys, I can get some tips to look at the wires. What is coil on plug? So let's go with a 4-cylinder engine. The old 4-cylinder engine had a distributor, right? Here's the distributor. It had 4 spark plug wires. And then it went to the spark plugs. So it had 4 wires, distributor, spark plug had this. This was driven by the cam or the crank. Depending on just depends on the model. But anyway, this is a mechanical device that rotates. This goes around and it distributes spark. So what we did was we said, hey, let's get rid of all these plug wires that are all the problem, and let's put a coil on every plug. So now each cylinder has its own coil, right? So this is cylinder 1, cylinder 2. Okay, you get the idea, right? But every cylinder has its own coil, and it sits right on top of the spark plug. So what do we do? One thing, we created more costs because every cylinder has to have its own coil now, right? But nothing's changed. Because here we got power and ground, right? We got power and ground. So what do we still got to do? We still have to power up that coil, even though it's a updated fancy ignition system. It still needs power to make that coil work. Hope I'm not standing right there. But what do we got to do still? We have to ground these coils, right? And how do we do that? Now it's done in one of two ways. There's even an ignition module, but nowadays it's just ECM, or computer, whatever you want to call it. So now instead of having a set of points that wear out, we run these wires through the ECM. The ECM has sensors, so it knows where top dead center is. It knows the temperature, right? It knows the engine load. So the ECM can provide this ground at the most optimum time. So now all we've done is now there's a coil for every cylinder. That's why you hear people say, hey, my car's missing. It says I got a misfire on cylinder number 5. 90% of the time, these coils are bad. I bet you I've changed 1,000 of these in my career. I'm not kidding you. And usually what happens is when one goes bad, and I've seen it, you put in one coil. A month later, the guy's back and it's this coil. Then you change that one. A month later, you come back and this one's bad. When they start failing, more than likely they're all going to fail in a matter of time. Do I recommend you do them all? I don't recommend it because let's say these coils aren't cheap. Sometimes they're $100 a piece. If you got an 8-cylinder car, you're $800 to $1,000 in coils. So look what we've done. We taken the simple little distributor with a set of points that you could get, points for like $10. And now when you got a problem with the COP, now it's going to be $1,000 to fix it. Is it more efficient? Yep. They sure cost a lot to work on. Full on plug, really common. And here's the other thing. You guys that are listening or new, you do not have to take your car to a shop to do these coils. It's very simple. Okay, let's say you take it you take it and it says number 5 misfire and you decide, hey, it needs a coil. Okay, let me walk you through the bill, what that looks like when you go to a shop. Okay, so it's missing, right? The check engine light comes on. You take it to the shop. What's the shop do? They give you a 2-hour estimate. $400 in California now. So they give you a 2-hour estimate, maybe only an hour, depends. So they hook up a scanner that takes about 5 minutes to hook the scanner and pull the code. That's going to be $200. And they say, hey, you got a misfire on cylinder number 5. You're $200 in. You didn't have to have it towed. Now he says, well, it's going to take some diagnostic time to find a problem, right? So they're going to charge you 2 hours diagnosis. So there's another $400. The guy more than likely, he already knows it's going to need a coil pack. He already knows that. He's changed so many of these, he knows that's a problem. So then they call you back and say, hey, we found the problem. You need a set of coils and plugs. Because the plugs are right underneath the coil, so you might as well change them, right? So now your coil and plugs. Some of the plugs now are 20 bucks a piece on some of these platinums, right? So where are you at now? You're 600 bucks. Now you're going to spend $1,000 on parts. You know, you're $1,600. Now they're going to charge you labor to install these. They're probably going to charge you 3 hours to do the coils and plugs. So now you're another 600 bucks. I'm not exaggerating on this. You could be $2,000 into this. And all it needs is a set of coil packs and a set of plugs. Let me show you how easy this is to do. So in a shop, you could be looking at $1,500 to $2,000, depending on how honest they are, or you know how fair they want to be. This is what a coil on plug looks like. Let me see if I can draw it. I'm going to draw it so you're looking down on it. So basically, it just looks like this. It's got a hole right here. It's got a boot that goes over the spark plug, right? And it's got 2 wires coming out for the connector. This is how easy this is to do. I could teach a 10-year-old kid how to do this. It has a little 8mm bolt right here. You take this bolt out, right? I need to do a video of this. You take out this bolt. There's a connector right here. You squeeze it and unplug it. You twist this and pull it out, and a coil comes out with the boot and everything. So it's basically one bolt, a clip, you unplug that, get this out of the way, and then you change the spark plug while you're there because you got it out. And it's just basically like any other spark plug. You get a spark plug wrench, reach down in there, take it out. So you do that 8 times, you save yourself $2,000. There's no need to take a job like this to a shop to have it done. You can do it yourself. I don't care who you are. If you've never even picked up a wrench before, I could teach you how to do that repair and save $2,000. Okay, coil unplug is done. Let's go to let me get you guys set up on the bench real quick, and we'll just do something real fast, and we'll just probably call it a night after that. I want to show somebody that's never used a mirror before what to expect. And let me get you set up. This might be kind of, give me a second, guys. This is going to be kind of difficult. Take me a couple minutes. Just give me a minute or two. We're going to show, let's see, can I leave out there? I want to get this set up on the bench. So, give me just a second. I can go to 2 cameras. I'll make things so much easier. Go here. That way. Here. My bench is a mess, by the way. Well, I had a lot to get ready tonight. I thought I had all kinds of time, but man, I didn't. Not at all. I thought I was all slick and going to be all ready to go. Where's the battery? Let's zoom in on that. Can you guys see that battery halfway decent? Is it focused in? I don't know if I can focus this or not. Yeah, it will let me. Hang on. Let me get a better. That should be pretty good. I still got you guys? Yeah, okay. Let me get some light over there. Looks like we use a little light. Okay, I think you can kind of see that. Can you guys see that all right? Let me see. Where's my phone at? So my phone gets me an idea of what it looks like. It's kind of like you want. Let's turn it sideways like that. This vertical is tough because you can only get a certain, we can only get so much of a view. Boy, if this, you can let the camera catch up. It's kind of some lag there. Give me just a second. I'm waiting for the video to catch up. This is kind of tough. There's such a lag. That's not too bad. All right. You guys still there? Don't blame me if you're not. So I'm going to just hook up a basic test light. So people that don't even know any better, they can understand how that's done. And then I got a coil all set up here. I want to show you how we can just use that. We can use that, like I said, where you can become the points and make it fire. The right one. I got both of these. I should have used a different color. Let me take this off. So here's the ground. Those things won't matter. Anyway, I should have tried this earlier. So there's the ground, and you can see when you make contact with a power and ground, the light comes on. So all the test light is telling you, hey, I got a power and I have a ground. Okay? So if you lose your ground, see what happens? The light don't light. You lose the power, the light don't light. It's no different than any other circuit. You look on a light bulb, a fan, whatever it is. That light will tell you if you have a power and a ground. So I'm going to show you what we did on the bench here. So what I did was I just wired up a coil, just like you would in the vehicle. Long cord for that, so I can do this. Let me take this off. So what I did, I just wired up a coil right here on the bench, power, and a ground. And then what I did was you see the spark plug, I just ran a ground wire from the spark plug to the battery so it's grounded, right? So right now, if I take my test light, I'm sorry, guys, I got shit going on. If I take my test light and I go right here to the battery, it lights, right? Just like I said before. So you go over to the coil, say, hey, do I have power to the coil? Yeah, I do. I got power. So what it's looking for, it's just waiting for a ground. Let's get rid of the test light. Next time, I think. So what I'm going to do, so right here, so what I've done now, this is the other wire that is hooked to the negative side of the coil. So this is power. This is an open wire that I got right here on an alligator clip. And when I touch ground, Yeah, anytime I try to focus, it takes the camera out. That's not good. This software. So what happens when you go to focus, it switches to the other camera. I'm gonna flip over, just work off the desktop now. I can get the other camera going, but we're kind of done with that camera, probably pretty much. Get some light over here. Actually, actually, this camera's not too bad, really. What's it look like on the vid? That camera's not too bad, really. Well, this is a laptop camera. So eventually, what we'll do is I'll be able to talk to you guys like this, and then I'll have the other camera set up on what we're doing. Yeah, I appreciate you guys that showed up tonight. I hope somebody that was here got something out of it. 'Cause I know it was kind of basic, but I kind of think I need to start there. Because a lot of people that are coming in are really basic, learners. They're just getting started, and truth hurts. Aftermarket catalytic converter, cheap, really good deal. Here in California, they won't let you do aftermarket. It has to be the exact cat that you on the vehicle. They get underneath there and they even check the number. Well, my badass Prius that was stolen. What it cost you for that catalytic converter? Truth hurts. You guys, give me your honest opinion on the class tonight. Was it halfway decent? Let me who's they. Truth hurts, dude. So in California, they won't even sell you they won't install a catalytic converter unless it's the actual one that came from the factory. That's why it's so expensive when that happens here. $1,000 to buy a catalytic converter. What vehicle it is? I got a fix for that. Something I've been working on for a while. I just got to put some money together so I can launch it. Catalytic converter thing is ridiculous. 450. That's a good deal. See here, you can't get by with that. There's no aftermarket catalytic. It has to be verified for the vehicle. It has to have a factory OEM number, and they'll actually get right there and check it. A lot of times you'll see them with a big mirror going underneath, looking, making sure the converter hasn't been changed out. Doing today. Hey, only um, Carson, you just showed up. Were you here early? I'm doing all right. I messed with the boat a little bit today, and I got some work done. I got that boat work running though. I just got to get some information. Issues with the linkage throttle. I'm trying to figure that part out, but I think that boat was. You're at work, yeah. There's nothing wrong with that. Good that you're at work. I'm going to be going back to work pretty soon, but 2 more weeks. 3 more weeks. I'll be working 3 days a week. I work Monday, Tuesday, Wednesday this year. Take off the rest. I'll have 40 weekend. So that'll give me a chance to work on the stuff. I'm going to try to do these. I'm going to try to do these educational trainings And I'm going to keep them really basic. Tonight was a little hectic because of the camera situation. Kind of, it wasn't too bad. It looks different. You doing it from your PC? Yeah, yeah. I could switch over, but we were at the end of the live. Not at the end of the live, but we were done messing with the ignition. They had it on a whiteboard, so I figured I'll just live on the how is it different? Like noticeably different? Is it clear? I thought the visual would be better on the other camera. 1 more year, no more work, I'm gonna retire. I did the same. Truth hurts. I retired for 5 years and had to go back to work. That's why I'm working now. I was retired. I retired at 55, and then I lost my wife. I didn't have enough money to keep up on stuff, so I went back. Yeah, yeah, it does look. It doesn't. I can't tell on. I should look at my phone to see how the live looks. Let's see what this looks like. It doesn't look too bad, though. Actually, it's not a bad camera for a laptop camera. You know, I'm surprised. It looks pretty decent. Not too bad. The audio is bad. How's the audio? I can switch back over to the other camera. I was just being lazy. I was like, well, we got through all the teaching part. I'll just do it off the laptop. Makes it simple. I had to go out there and crawl underneath the hood of my old Chevy to get that coil out. Well, next time we do this ignition thing, I'll have a board set up. I ran out of time today. I wanted to set up a board with toggle switches and stuff so people could understand. Maybe too good, huh? Shows my how ugly I really am, huh? Actually, the camera's not bad on these laptops now. The thing is, you can't move them around, and you can't go live if you want to be outside or if you want to show something that you're doing. The laptop makes it tough. You can't point it around. It's got a front-facing camera too. But, I've never used it for that. I always use the phone or the other camera. I like the other camera better. I wish I would have bought a camera that had exchange replaceable lenses on it. That's one thing I bought that camera because it was a deal, but it's more for vlogging. It doesn't do a good job at like getting a good close-up shot of stuff. Like if you're out, you want to get a shot of say something across the street, you can't get it because it's a fixed lens. It's really, it's like a fisheye lens that it has in it. It's good for like vlogging type stuff. Really good. You know, bought that whole setup for like $600. Came with everything with the memory card, and I upgraded the audio on it, and I got a ball head for it. It's easy to get $800 in the system. It don't take long. There's another one that Sony makes, CV10, that's it has replaceable lenses. So you can do this, or if you're out and about, lens on, you know, so it's a little bit better camera. Anyway, what are you guys up to? Anything exciting? I know it's only Tuesday. Tuesday or Wednesday? Today's Wednesday. I was supposed to do this yesterday. So we're gonna do Monday, Tuesday, Fridays now. So Mondays we're gonna do motorcycle Mondays. We'll just talk about motorbikes and dirt bikes, Harleys, and motorcycles. And then this lives for at night. Tuesdays I'm going to teach like I did tonight, and I'm gonna keep it pretty basic. Like I might just even do like this is an alternator, you know, this is what it does, you know. Okay, well, you can learn. There's little things you can learn along the way. on all that stuff. Alternators are one that people don't understand really well. And really, there's only 3 wires on an alternator. Once you understand what they do, it becomes very simple, you know? It's not hard to diagnose an alternator issue. That's what we're kinda trying to, move into is trying to show people that we can save you money if you're willing to just do basic stuff. You know, there's no reason anyone should ever take their shop to change an alternator. An alternator is like a bolt on top, take the main battery post off, usually a connector and 2 bolts. And, you do it, and they'll charge you, $300 to change that out, and that's not including the diagnosis time. So, we can teach a lot of stuff to basic automotive that can get people, out of the shops. Some things you're gonna wanna take to a shop, don't get me wrong, but there are other things that you can do yourself. We can teach that here, and that's what I'm hoping is a larger audience. Hey, before you guys go tonight, if you would go to the links, below in the description, and you just look at some. I don't even care if you buy it, just take a look. Got some good talks on the links tonight. Let me see if I got one up here. Do, 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 do. Here's that Power Pro I was telling you guys about. Here, I'll share my screen with you. This Power Pro, man, I tell you what, if you don't have a Power Pro and you do a lot of this kind of work, you should check it out, man. Hang on, got the wrong thing going. Share my screen. Supposed to go to the eye doctor tomorrow. So this is that Power Probe. So this is a good tool. I have one of these in my toolbox at work and one in the tool room. And these things are they save you so much time. And there's 2 different ones. You can buy just the Power Probe for like 130, I think. And then the big kit's like 160 or 165. But with this thing, it works like a test light. It has a red and a green LED on it, so it shows you power and ground. But that little rocker switch in the middle there, you can apply power or you can apply ground. And the one that applies the power, you can check for a short to ground. So say you got something that keeps popping the fuse, you can hook that to the power leg, and when you push it, if it goes to ground, there's a circuit breaker in there that pops, and you'll hear it go pop. You can reset it right there on the probe. So it's got really long leads on it. That's what I really thought. Looks good. Okay, no. So what's nice is that you can hook this up to the battery and walk all the way to the back of the vehicle. I use it all the time for trailers and stuff. I use it all the time for trailers. You just hook it up and you can walk back there to the 7-pin on the trailer, and you can check for power, and then you can apply a power on the like if you want to check the trailer in, the part that's going in the trailer, you can just power those up one at a time and watch the lights come on. It's really a good tool. I don't know how people you do any kind of troubleshooting like electrical. I don't see anything done. It cuts your time in half. Once you learn how to use it, and then, once you use it a little bit, you'll love it. So a lot of these things, I only show these like products that I think are a big deal. And then if there's anyone here looking to like start their own toolbox, there's a good deal on a Craftsman's. I know Craftsman's not made here anymore, but what is made anymore? My first tools that I started in the industry were I still have a lot of them. The cool thing about Craftsman is they warranty your stuff. No, you break something, you take it, you know, they don't mess around with it. It works good. I still have stuff that I've had forever. There's a kit in there right now. It's like 40% off, I think. It's like 69 bucks for a real nice, it's a half and 3/8. No, I'm sorry, quarter, 3/8 socket set. I think for like 139 bucks, man. Let's see. Um, sharing that. Anyway, we're eventually eventually what I'm gonna do is try to get like a tool list going for, let's say, a guy that's just got his first hot rod, or a young kid that's starting to work on a car, or let's say the repair industry, start going to work in a shop. Try to put together like a tool list for like under $1,000. I'll tell you, tools, man, when you go to work as a technician, tools are a big expense. I mean, huge. I've got friends. I don't have to buy my tools anymore because where I work at, they supply my tools. I have friends that have been working in the industry. They've got like 60, 80,000 dollars in their toolbox just to be working somewhere, and you pay. It's a write-off. You have to pay for it. And then if you lose a tool or break a tool, you got to replace it. When I first started in the industry, when I first started out, my house, 200 bucks a month. And my house, my tool bill was six. So I was spending 3 times the amount on tools than I was on my rent. It don't take long to get $20,000 worth of tools. So anyway, we're gonna try to put together a package, like just not upper end, not cheap stuff, but like middle range, like OTC, Craftsman wrenches, Craftsman channel lock, stuff that's decent quality without breaking the bank. Are any of you guys working in the industry still, like wrenching still? How's the audio? I don't even know. I should turn this on. I could probably hear it. Yeah, it's pretty clear, huh? Almost better out of focus a little bit. See my all my gray hair a little bit. Tomorrow I got to get my eye looked at. I've been struggling with this left eye. Tomorrow they're gonna pre-op me to have cataract on the left eye. I tore my retina and left a scar, so they got to go in there and fix that, get that cataract out. I thought they just went in and like did something, but they actually take your lens out of your eye. They take your eye lens out and give you a new lens. They said it takes like 15 minutes, 7,000. How should I get paid 7 grand to do 15 minutes worth of work? I got today going, man, if you did 10 of those, you could make 80,000 a day. That's highway robbery, man. Thinking about I better get to the Philippines faster, man. I'm surprised we didn't see Maggot tonight. He must be busy harvesting his tomatoes or something. I've been trying to get all my stuff done because I'm going to be going back to work. So I'm trying to get everything done before I'm going to be short on hours. It'll start getting dark sooner, and I got all these projects. I got the truck, man. It's doing good. I got it. All I got to do is do the brakes on the truck. It's ready to go. That got a 250 IDI 3. Just do rear brakes on it and bleed it. Man, that was what I try to teach. Well, I'm trying to teach on here. If you just learn basic automotive, you can do pretty well picking, especially if you especially, what I love hearing when I talk to somebody on Yeah, it doesn't crank. I'm there. Because usually no crank either means either the motor seized up, it's the start circuit. Start circuit is easy fix. It's going to be the starter, or it's going to be the switch, or it's going to be wires to and from. So it's usually like an easy fix. And you see sometimes people put stuff up that's pretty new, low mileage, and they say it doesn't crank. But nobody wants to buy it because it doesn't crank, it doesn't run. You can pick them up, dirt cheap, a little work on them, and you got a anyway. So 1 to 10, how was the teaching tonight? Was it worth watching? Be honest, you're not gonna hurt my feelings. Basic teaching stuff going on. We're gonna start, and I'm thinking about really doing like a podcast, like early morning podcast. Just talk about automotive stuff, maintenance, how to take care of your car, that kind of stuff. The life is pretty nice. I like doing it. So you just kind of get to be yourself instead of having to worry about, oh, did I get this information in? Was a camera perfect? Was the audio good? Because you can spend a lot of time on it. I mean, I've spent 8 hours on videos before, sometimes more than that. By the time you get them edited, like I got one right now. I just did all the footage when I did the fuel leak on that 7.3, and I just got to go through it and do all the editing. But man, the editing takes forever, man. I wish I could get rich and famous so I could hire somebody else to do all the editing. It takes forever. It's not much fun either. Did you guys watch the live tonight, or did you just listen? I'm thinking a lot of people just listen. Or we've had a lot of people say that they just listen to the live. All right. Well, I think I'm going to bail out of here. I appreciate everybody that showed up at the live tonight. And hopefully there was something in there that brought you some value, some more thought process or training, be more prepared. I was kind of scrambling around tonight right at the end trying to get everything ready. Anyway, thank you guys that all that came. I appreciate you showing up. And if you would, before you take off, go check out the links in the description. It helps us. All right, guys, take care. Later.